Good morning, everyone, and thanks for joining us today. My name is Galen George, Director of Applied Science at Felix Instruments, and today we're going to look at what more than 500,000 non-destructive fruit scans tells us about the future of freshness and how large-scale representative data is reshaping the way the industry thinks about maturity, quality, and post-harvest performance. There are two goals for this session. One is to show you what our data set and the broader scientific literature tell us about variability across fruit crops. The second is to connect those insights to the models behind our instruments, the global F751 quality meters, and the custom or local models we build with customers using the F750 platform. Before we dive in, though, I'll be introduce myself properly and cover just a few housekeeping items. For those of you who haven't met me, I come from a background in biochemistry and food science, and for the last 6+ years, I've led the Applied Science group here at Felix Instruments. My team works directly with customers around the world, helping them design sampling strategies, build models, deploy instruments, and interpret data across orchard, packhouse, ripening, and retail environments. So before we begin, just want to let you know the webinar will be roughly 20 minutes, followed by a Q&A session. This session is being recorded, and both the slides and the recording will be available afterwards. If at any point there are any technical issues throughout this session, such as my audio or video cutting out, the slideshow not advancing, or anything like that, please feel free to post in the chat. Hunter Weber, our marketing coordinator, is moderating today's webinar, and he will inform me if any of those issues arise. He'll also be posting any relevant links in the chat. So if there's a link that is in the webinar that he wants you to click on, then that'll be posted in the chat so you can actually physically click on it. If you do have questions that pertain to the content that I'm presenting in today's webinar, you can submit those questions at any time, but please use the Q&A function in Zoom and not the chat. And at the end of the session here, I will address as many of those questions as possible. So with that, let's go ahead and start with why this topic matters right now. So across the industry, from growers to pack houses to retailers, one issue keeps coming up: increasing inconsistency in fruit quality. There's a substantial body of research documenting post-harvest losses and retail shrink in fresh fruit and vegetables. Meanwhile, we hear from customers that fruit is behaving less predictably in storage or in ripening rooms or on the shelf, even when traditional maturity metrics suggest it should perform well. And there are a number of forces that are driving this. Things like environmental pressures and demand for higher yields, faster and more compressed logistics, aggressive retail timelines and promotions, and rising consumer expectations. Underneath all of this is a deeper issue. Fruit is highly variable, and many sampling protocols were not designed to capture that variability. The tools that we build, the F750 and the F751, and the models that power them were created to address exactly that challenge. So let's put those tools into context. Our work in modeling and non-destructive measurement is centered around two instrument families. So first is the F750 Produce Quality Meter, which is a general purpose NIR platform that measures internal quality and serves as the foundation for custom models. It's widely used in R&D, breeding programs, supply chain QC, and academic research. Second is our F751 series of quality meters, which are commodity-specific instruments preloaded with robust global models for commodities like avocado, mango, kiwi fruit, and table grapes. These meters are designed for turnkey deployments across regions and seasons. The 500,000 scans that we referenced throughout this webinar come from global calibration development that we've done, customer-specific modeling projects, and internal R&D across a wide variety of crops. This data set represents multiple continents, multiple cultivars, seasons, and maturity ranges. And it's this diversity that allows us to build robust models. So let's look at the global models first. For our global F751 models, we intentionally build large, diverse data sets. These include multiple countries, growing seasons, and a variety of cultivars where applicable, and a deliberate span of maturities as well, from early to late. Each data point combines a non-destructive spectra with a high-quality laboratory reference. So a value such as dry matter, soluble solids content, or also known as bricks, acidity, pH, color, and more. We then independently validate the models on data the algorithms have never seen. The result is a robust, ready-to-use model designed to perform reliably across different regions and growing conditions. These global models are ideal for standardized export programs, vertically integrated supply chains, and operations that need consistency across many kilometers and many months. But global isn't always what a customer needs. Sometimes a local focused model is the better solution. The F750 platform allows us to create local or customer-specific models tailored to very specific contexts. These are commonly developed for commodities like berries, citrus, apples, pears, stone fruit, melons, or niche regional crops. Local models are built on customized sampling plans that reflect a customer's real growing regions, varieties, and QC specifications. They deliver precision. The calibration is tuned to the customer's actual supply chain and desired maturity targets. And this approach is especially beneficial when working with proprietary cultivars, unique microclimates, or new production regions where global datasets may not fully represent local conditions. So now that we've framed our modeling ecosystem, let's look at the scientific foundation behind it, the variability itself. Decades of peer-reviewed research across avocado, apples, grapes, berries, citrus, mango, they paint a clear picture. So at a macro level, tree-to-tree variation within the same block is often substantial, driven by differences in crop load, microclimate, and resource distribution. We kind of zoom in on our sources of variability. The next level we can observe is canopy position, which has also been shown to have strong effects on variability. External fruit may have higher dry matter or oil content or soluble solids content than interior fruit. And then if we zoom in even further, internal composition is not uniform within a single fruit. So sugars, acids, dry matter, they often vary across the tissue. When you look at these layers of variability, they stack together. A sample of 5 or 10 destructive fruit often cannot characterize the real distribution. This is exactly why our sampling design for both global and local models is built to capture canopy, orchard, regional, and seasonal diversity. This variability shows up in how fruit behaves. So lots with broad maturity spreads tend to ripen unevenly. Under mature fruit can be slow to soften or fail to develop flavor. Over mature fruit may exhibit early breakdown or internal disorders or rapid senescence. And even when the average maturity looks perfect, it's the variability in the tails, like in the low dry matter or high dry matter outliers, that often drive the majority of storage failures and consumer complaints. From the consumer's perspective, this becomes the fruit lottery, essentially. And from a modeling standpoint, it's a reminder that understanding the distribution is more important than understanding the meat. So let's now talk briefly about the metrics the industry relies on. Dry matter is a very common maturity metric, especially in avocado because it is strongly correlated with oil content, which is a key component of eating quality. It's a practical and validated proxy, but its significance only becomes clear when understood in the context of variability. Firmness measures only measure a very small depth of tissue. It is informative, but it's localized. Brix and acidity work together to shape flavor perception. So in commodities like berries and citrus, the sugar-acid ratio is more predictive than sugar alone, and that's a very well-documented case. And of course, we can't forget about ethylene, which I spoke about a lot in our last webinar. It is a major driver of ripening in senescence, and even small differences in ethylene exposure can significantly affect shelf life. So our models often predict things like dry matter, soluble solids content, or Brix, acidity, internal color, or other internal quality parameters. But the limitations of these metrics must be understood in light of distributional variability, which brings us to the next concept. Small, destructive samples often produce data that appear nicely centered, a nice normal distribution that looks healthy. But with small samples, the tails are almost invisible. And it's the extremes, the underdeveloped berry, the low dry matter avocado, the overripe mango, that often drive the worst outcomes. So non-destructive tools allow us to sample widely enough to reveal the true distribution and manage those tails. Before we discuss the modeling strategy behind that, let's acknowledge how this manifests at the end of the chain. Retailers face significant financial impact from fruit inconsistency. In direct conversations that I've had, large retailers have shared that a single commodity like strawberries can generate multi-million to tens of millions in annual shrink. Those numbers are internal, but they align with well-documented public trends. Across all categories, retail shrink in the US exceeds $100 billion annually, with fresh produce consistently among the largest contributors. Reducing inconsistency, improving shelf life prediction, and minimizing extreme outliers all have a direct economic impact. Representative sampling and strong models are key parts of that solution. This is where non-destructive NIR becomes essential because it doesn't destroy fruit. You can screen a large number of samples rapidly. This dramatically reduces the cost of gathering enough data to understand a whole lot of variability. High volume sampling, you can see the maturity or soluble solids distribution instead of relying on a handful of destructive tests. And this richer data set becomes the foundation for robust, reliable models, the same models we deploy in the F750 and F751 across field, packhouse, and post-harvest workflows. So let's look at how those models are built. Our modeling workflow involves four major components. First is rigorous sampling design, where we capture real-world variation across canopy, orchard blocks, regions, cultivars, seasons, and even within the fruit itself. Second is accurate reference analysis using validated laboratory methods such as oven drying for dry matter content, refractometry for Brix, titration for acidity. And then the third is advanced chemometrics, where we link non-destructive spectra to lab values using machine learning, PLSR, or a variety of other modeling techniques. And then the fourth step is independent validation and ongoing monitoring, which ensures reliability across seasons and allows for recalibration as conditions evolve. This same process supports both the global F751 models and the customer-specific F750 models. Which brings us to a point many attendees ask us about, which is custom modeling. For customers working with unique cultivars or emerging commodities, or specific QC targets, we do offer full end-to-end custom modeling services. In these projects, we help design the sampling plan, coordinate or conduct laboratory analysis, build and validate the model, deploy it onto the customer's units, and then train their team in the workflow. Local models are ideal when you're working in a new growing region, when you're targeting proprietary flavor or maturity specifications, or managing cultivars that aren't covered by global F751 devices. We continue supporting the model over time, helping customers refine or expand it as they collect new data. So as an example, we can talk about avocado. The avocado illustrates these principles very clearly. So published research shows strong canopy position effects and significant tree-to-tree variation in dry matter and oil content. Our global F751 avocado model is built to capture that variability across countries, seasons, cultivars, and production systems. We've collected data in most major growing regions across the world, and we've been collecting data for the past 7 to 8 years now. We have collected data on more than just Hass. We have Shepherd data, Maluma Hass, and a few other cultivars. And we've collected that data at the field, in the orchard, at the pack house, at the retail outlet, and everywhere in between. We've also collected that data from early season to super late season to get that full maturity range of data. So customers use the model that we've created to map their orchards, to help guide their harvest decisions, to segment bins by maturity, and improve ripening room consistency. Where needed, we've also then built local models for specialty cultivars. Think like smooth skin tropical varieties, or high elevation production even. So in certain regions where they're producing at very high elevations, where the climate and the soil types are just too different, and regions with unique climate patterns. The goal in both cases is the same, right? So with whether it's the global model or the local model, the goal is to make variability visible and manageable. Now, while most of our customer base typically consists of orchardists, pack houses, and importers, I want to make it clear that freshness doesn't end at the pack house. Research shows that ethylene exposure, temperature fluctuations, and airflow patterns in the retail environment are major drivers of shelf life. Open displays often mix ethylene emitting with ethylene sensitive commodities, which can compound the effect. So to reduce losses and improve customer perception, more and more retailers are now embracing quantitative tools, temperature and ethylene monitoring, improved air management, and non-destructive QC at receiving. The more the supply chain measures, the more predictable freshness becomes. Looking forward, several trends are converging. One is the rapid expansion of non-destructive internal quality analysis. The second is integration of quality data across the orchard, pack house, distribution, retail, entire supply chain. The use of AI and robotics to achieve truly representative sampling at scale is a big one. And greater movement toward standardization and validation of non-destructive methods. The common thread is greater visibility and better decisions driven by richer data. All of this leads to a fundamental mindset shift. Historically, the industry relied heavily on tradition, experience, and small destructive samples. Those tools aren't wrong. They're just not enough for the variability we now know exists. Non-destructive measurement and robust modeling allow us to see maturity and quality in far greater detail. And when you see more, you can manage better. More data leads to better harvest timing, which leads to better lot management and leads to better consumer outcomes. And that's the shift we're seeing across the industry. So, to close, 500,000 fruit scans combined with decades of scientific research tell us that fruit variability is real. It is large and it is manageable when you can measure it. Our F750 and F751 instruments, supported by robust global models and customized local models, are tools designed to make that variability visible so growers, packhouses, and retailers can deliver more consistent quality. If you're already working with our instruments, I hope today helped clarify how the models behind them are built. We do have a multi-part webinar series on chemometrics available on our website and on YouTube if you're interested in learning more about this process in greater detail. If you're considering a custom modeling project or want to explore how non-destructive measurement could be applied to your commodity or program, I would be more than happy to discuss that with you after today's session. You can get in touch with me via email. You can give us a call at any time, and we'll be happy to touch base with you to talk about it more. So thank you for your time. That was about 22 minutes, looks like. So that's exactly what I was kind of aiming for, to keep this short and sweet. I just want to go ahead and open this up now to the questions. And what we'll do is, if I can't get to all the questions, you can just send me an email, or I will send you an email to respond to those after this is over. Once again, thank you guys for your time. We'll open up the floor for Q&A. First question is, did the analytical data reveal any false positives in traditional visual inspection? Meaning fruit that looked great but was actually of poor quality. Yeah, that's a great question. So the analytical data that we collect with the spectra, which can see inside of the fruit, which the visual eye cannot see, oftentimes reveals that fruit is not necessarily as mature as you think it is. This is especially true in the case of fruit that change color as they're ripening, or fruit that have tough exteriors like avocado, where it's kind of difficult to know whether or not what's inside is really ready for eating or not. So yeah, that's a scenario that happens very often, is that this kind of technology and testing can reveal those kinds of false positives. The next question is, did our scans help identify optimal harvest windows more precisely than traditional bricks or firmness alone? Yeah, so this comes to the question of variability with the old traditional sampling methods versus the more big data approach, right? So when you're doing it in a way where you're taking, let's say, 5 samples per block, or in a post-harvest sense, we could say 5 samples per truckload, inbound truck. There are many cases where that has led to a shipment or a harvest, a premature harvest, because the 5 fruit that were selected at random all passed the traditional bricks or firmness test. But when you take a device that's non-destructive like R751 and you scan, let's say, 20 to 50 of those fruit instead of just 5, you find that the average is actually 1 or 2 bricks less than what those 5 fruit were. And so that it has absolutely helped with post-harvest, as well as with Fruit Maps, our software, where people have used our device to more precisely and kind of, in a big data sense, gather more data to help them identify where exactly on their orchard they are ready to harvest, as opposed to assuming, this block is ready, which means all these blocks around it are ready. It allows for a more precise way to plan that harvest out. I got another question here. Do you see non-destructive scanning becoming a universal QC step in the next decade, or is there a bottleneck preventing broader adoption? I am very hopeful that NIR and non-destructive techniques and technologies like this will become a very widely accepted and universal step. The bottleneck does exist, and I think that the bottleneck for the most part is that there are these techniques we've been using for decades and decades that have been accepted by various scientific standards, different organizations that create scientific standards, certifying bodies that accept these methodologies and have, proven out that they are effective at measuring the trait that they are measuring. The bottleneck is one, getting those kind of agencies to actually test and adopt this kind of technology and accept it into their list of accepted technologies and techniques, or the protocols for doing these testings. The other bottleneck is just general, I guess, distrust or general unease at adopting new technologies at the commodity organization level. So, for the most part, most growing regions across the world have some kind of overarching organization that helps to support the avocado industry or the mango industry or the kiwi fruit industry. And it's those organizations that need to work with us and other manufacturers, I guess, of NIR technology at the post-harvest and pre-harvest level to come up with, the actual protocol for using the device and what gives them the best results to do that testing, to invest in that testing, to actually, determine what is the best practice with our operations, to use these devices. It's totally feasible to do. It's just, it requires a little bit of time and definitely a little bit of money to actually take that step. And, with the issues that I talked about earlier with, fruit losses and issues with quality consistency, money, I feel like, is tighter than ever. So that's just not something that the risk that not enough people are stepping into. The problem is that it's kind of a double-edged sword, that if you don't adopt it, then you risk continuing having bad quality fruit and fruit losses. So it's, if you actually take the risk, you're going to see drastic improvements. So there's a couple of those bottleneck stages in there that I see, and it can be a little bit frustrating. But I do think that we'll get over those hurdles in the next decade for sure, and that we will see this technology being implemented at that level. That was a great question. The next question: as our data set sizes have been increasing over time, do you see that your models improve on new data sets? Yes, to an extent. So I think that what we've observed, especially when it comes to, I think the number one thing that we see this in is seasonality. And so as we add more seasons to our data set, we come to a point of, I guess, diminishing returns on model improvement. And so the other aspect of it is that we have to continue to kind of, selectively make sure we're only adding high quality data to the models. Because if you just mass add whatever data and don't do any kind of QC checking of it, then that obviously is going to throw the models off over time. It's going to actually make the performance, either decrease or just not improve. But we do start to see diminishing returns on seasonality so far. What I've observed is that the return of adding in a new season's worth of data and model improvement starts to diminish after like the third or fourth season. 4 seasons, I think, is a good metric for us, as far as with 4 seasons, where we don't really see a seasonality change with a new independent validation set from a later season. But regardless, it's best practice to at least add a little bit of data. And at least that's what our best practice is for these models, is to add a little bit of data in from each season, just so that, especially as we're using new machine learning techniques, just to make sure that, we are just limiting ourselves to a 4-season data set. But as far as how much those later seasons improve the data set, it's fairly marginal um, at best. Yeah. The next question is, have we done any experiment for blueberries, other small fruits, blackberries, raspberries? As a matter of fact, we have. We have used the F750 to create models, acidity, Brix, pH, those kinds of models for all the different berry categories: strawberries, blueberries, blackberries, raspberries. We do have validation reports on our website. If you go to our website and you click on the F750 product, and then you click on the tab that says validation reports, it'll take you to a screen where you can download the validation reports for all the different berries that we've done. And it works quite well for small berries. We do have a funnel, what we call a berry funnel attachment for the device, so that you can put multiple berries in and it holds it. As you can see from this device, just trying to balance a couple berries on there might be a little difficult. So we actually have an attachable funnel that allows you to fill up that with berries and let it hold those berries more easily as you take your measurements. The next question is, can you tell me if your device works with bananas? Is it able to measure banana quality and give accurate results? Typically, the limiting factor with our technology is skin thickness. So commodities like, let's say, watermelon are very difficult to get any kind of useful information about the flesh, just because the light has a hard time penetrating through that rind. With bananas, we haven't done too much work with bananas, but I think it would be worth exploring. I can't rule it out as not working. I would say that there is a chance that it could work for bananas, and we just would have to test it first to determine if that is the case. The next question is, how much does it cost, and can you send one in Greece? The answer to that question is, feel free to reach out to us directly. You can email me directly. You can email sales@felixinstruments.com. And we can let you know how much the cost is. We do sell them all over the globe. We have a distributor network that usually handles specific areas throughout the world. And so we do have a distributor in Greece. I believe that we could put you in touch with, who can get you set up with a unit. So absolutely, we can get that information for you. And then we have another question here of, which of the parameters, Brix, dry matter, acidity, is the dominant one for shelf life? Do you have any idea what drives harvest, I think is the word, with large outliers? What practices produce very heterogeneous crops? What, in your experience, was the biggest driver of difference between spectra? Wow. Okay. So it's a large multi-part question here. So let me do this one segment at a time. So which of the parameters is a dominant parameter for shelf life? I would say that there isn't a single parameter that is a dominant one for shelf life. Although one of the biggest drivers of loss can be loss of water, right? So just respiration of the fruit. And so the inverse of dry matter is moisture content, right? And so looking at the loss of moisture over time can help you, predict your shelf life, right? So that is one thing I would consider. But all of those parameters are going to impact shelf life to some extent. Ethylene obviously being the biggest driver of exogenous factors that can reduce shelf life. But I would say that it's really a combination of monitoring all those things that is going to be the best practice. And as far as your next couple of questions, I'm not really sure what you're trying to ask here. So what I would ask is that you send me an email directly, because I'm not really sure what it is you're asking. So if you can just send me an email directly, I'll be happy to continue this discussion with you over email, just because I'm not 100% certain what it is you're asking. Um, yeah, so that would be Harriet. Just feel free to send me an email, please, and we can continue that discussion. The next question is, how useful are these devices on thicker skin fruits? So that was a great question. I kind of already said watermelon is just, unfortunately, rind is just too thick to get that light to penetrate into the flesh. Citrus, however, there is going to be some citrus that it works really well with. We have success with mandarin and even like things like, lemons and limes and other citrus, but like something like a really thick skin, an evil orange or a grapefruit, even maybe, could be potentially, not as easy to use the device with. The spectrum might not be as good. Um, so yeah. And then we have one more question here. See here. I'm sorry, I'm just reading this question to myself because it's a very long one. Oh, okay. This is a support issue with the F950, which is an ethylene analyzer. So, Annabella, if you could please reach out to support@felixinstruments.com to get your F950 calibrated, then that would probably be the best bet for you to get that looked at. And then this looks like we have another question from Hudson. How does the data collection interact with breeding databases such as BreedBase? Great question. So we do have a lot of flexibility with how this data is sent and stored and basically it's really open source, and so you can send this data to any database that you want it to. As far as direct integration with specific brands of software or databases, that's not something we've really directed a lot of our energy towards. We're not really in the business of creating APIs and stuff like that. What we've done is just make it so that anyone from those companies could easily create a way for this data to be easily imported wirelessly from the device. So you could just upload it via Wi-Fi and have it go directly to that platform. There are a few QA platforms and other such softwares that we are actively working with to do that kind of integration with. It is, like I said, it's a pretty simple and straightforward way that you can go about doing it. So we kind of leave it as open as possible so that anyone can get their data wherever they need it to go. Here's a good question. Can it measure the amount of waxy bloom, which is the whitish compounds on most fruit, like berries and grapes and plums, on the fruit? Theoretically, yes. Theoretically, you could create a model that is using just like a direct reflectance spectra, and use that to create some kind of predictive model for waxy bloom. But typically, these instruments are mostly focused on internal traits. So defects, if there's some kind of specific disease or defect, bruising or browning or other kinds of however the disease manifests, and then quality traits like the quality of the internal flesh. But theoretically, with something that does just direct reflectance of the external part of the fruit, could do something like that. The next question from Dario is, are we still considering building a GitHub repository? Yes. So we do have GitHub repositories that we use internally for right now for all of our model building. But yes. And Dario, I've been meaning to get in touch with you actually. So we'll touch base here soon and talk about, making sure we can get some of these larger data sets to be potentially more public so that other researchers can, do all sorts of researchers that are far more knowledgeable, like Dario, far more knowledgeable in machine learning and stuff like that, to test out all these new different ways to do modeling, and see if we can improve these models even further. The next question is, can these NIR devices measure leaf bricks? Yeah, they could, but we do also have a leaf spectrometer that would be even better suited for that job. Our other business, CID Bioscience, has a device called the CI710S leaf spectrometer. Um, the 710S has a leaf clamp, so it actually is meant to measure leaf tissue. And it also is a visible to near infrared spectrometer. And so with that, you would actually probably have an even better chance of creating a really robust bricks model because it's just an easier form factor, and you'll get more consistent readings with that clamp style on the top. So I would recommend checking that out on our CID website. The next question is, so I did at the start of the presentation, I did say that this presentation will be available as a recording, and the slide deck will be available as well for you. So yes, if you did miss part of the presentation, you will get that afterwards. I guess got another question about portable gas analyzers. So yeah, do we have any information about using a portable gas analyzer after when you're opening a container during receiving? Is it possible to use it to quickly detect potential problems like elevated ethylene or CO2? Yeah, absolutely. I would check out the webinar that we just did a few weeks ago, where I talk mostly about ethylene and all of our different gas analyzers. That should be available on our website and on our YouTube. But yes, absolutely, you can use our instruments. Have very rapid response times as far as how fast it can detect and respond to ethylene or CO2 levels. So that would be a perfectly reasonable use for our instruments. And yeah, we have many customers that are using our gas analyzers for similar kinds of activities. The next question is the variability of amount and its reflectance of surface wax a problem for measurement? Do we have to wipe the fruit? That's a great question. So luckily, our instrument is designed not to have any really strong interference from like specular reflectance or from direct reflectance, right? So like the shininess of the surface of the fruit is actually not part of the spectra that we're using in our analysis, right? We're using the interactant spectra, the light that's going into the fruit itself. Now, if the wax coating is super thick or if it's causing the light to bounce in all sorts of weird directions, then potentially it could interfere. But at the same time, if you're building a localized model and you're going to be measuring waxy fruit, then what you can do is, as long as you're building your model with just waxy fruit, then you should be able to get decent results that way. But the best practice is if you want to use a model that already exists that we've built, then yeah, wiping the fruit off is going to be typically what we recommend. To get any dirt, you don't want any active water, just condensated water droplets on there, stuff like that. So that is typically what we recommend. And then the last question here that I'll take is, can it be mounted on the top of a conveyor belt to analyze thousands of fruit as they pass through? So that's a great question. There's a big difference between the handheld NIR analyzers we make and inline NIR analyzers. There are lots of companies that produce inline NIR analysis machines, companies like Tomra, that are specializing in doing really high throughput post-harvest NIR analysis. The difference between the technologies is really mostly in how quickly we're obtaining spectra and how accurate that spectra is, and how accurate the predictions can be. So if you imagine, this being a single fruit or, small samples, I guess technically small sample size single fruit analyzer, we're getting a very precise measurement of that exact fruit. When you're measuring 1,000 fruit a second that are passing through a conveyor belt, or 100 fruit a second, then you're not going to have quite the the level of resolution in that spectra and those measurements. So it's typically more used as a general, just kind of, these are above a threshold, these are below a threshold, just a sorting kind of situation, and not so much a quality check. This is how much bricks, this is how much dry matter. It's not so much usually that kind of application, which is where these instruments excel. All right. And I believe that's all the questions that we have. If you do think of something else, feel free to shoot me an email and I'll be happy to help answer it. But otherwise, thank you all so much for your time, and I hope to see you on the next webinar.